A very good afternoon, participants. We'll wait for another 5 minutes for more participants to add. A very good afternoon to all the participants. I welcome all the participants for this session 8 of the 6-day FDP program. Today we have with us Mr. Stanley Jabadurai, who is an infrastructure engineer at Ocean Square. He has completed his master's from National Institute of Technical Teachers Training and Research, and completed his BE from Dr. NGP Institute of Technology. Sir, we are happy to have you here. You can take over the session now, sir.
Thank you, ma'am. Thank you. So the topic that I am going to deliver today is about the recent advancements in geotechnical engineering and
Sir, sorry to interrupt. Uh, your screen is not shared yet, sir.
1 minute, ma'am.
Yes.
Ma'am, now is it visible?
No, sir, not yet.
Ma'am, I think so. It is visible, ma'am.
Just a minute, sir.
Okay, ma'am.
It's still not visible for me. Participants, can you confirm if it is visible for you, for someone?
Yes, ma'am, it is visible.
Oh, okay.
Shall I start, ma'am?
Yes, sir, yes, sir, yes, sir. Please go ahead, sir.
Good afternoon, everyone. So, the topic that I am going to deliver today is about the recent advancements in geotechnical engineering and in an industrial perspective. So, the topic that I am going to explain you about the concept of digital twin in geotechnical engineering. So, first of all, I am going to explain what is digital twin and how it can be implemented in geotechnical engineering. Then finally, I am going to deliver you one of our live project that I have been recently worked out. So first of all, let me give an introduction about digital twin. In the 1960s, the NASA developed the concept of digital twin as a living model of the Apollo space mission. So during in 1960, during the NASA's Apollo 13 space mission, there is a problem that happened in main engine tank. So due to that problem, the NASA, in order to overcome that problem, the NASA developed a concept called as digital twin. The digital twin has been evolved because they need to predict the damages before it has been crossed their hands. So before the problem arises, they want to solve the problem. So in order to solve those problems, they have been introduced a concept called digital twin. So, what is digital twin? So, digital twin is a visual representation of a physical object, process, or system that is updated with real time data and simulates to reflect its performance, condition, or behavior. So, it is nothing but the visual representation of a physical object or anything. So, for example, in construction related, if you need for constructing a building, we will do the 3D plans and SketchUp, Revit, and many more 3D plans. We will work it out. So, as like that, in the digital twin also. So, in this, we will add the real time data, and we can able to predict with the help of these data. So importance of digital twin in geotechnical engineering. So the main challenges in geotechnical projects. So the main challenges that have been listed out were limited data availability. So we would have only limited data regarding boreholes. We can't able to visualize the entire borehole certainties and subsurface. So mainly the subsurface we can't able to work it out the soil strength. So in order to overcome that, we can also use the digital twin concept in this. So the risk of failures. So uncertainties in soil and rock behaviors can lead to unexpected failures such as landslides, foundation settlement, or tunnel collapse. So in order to overcome all these things, we can also adopt the digital twin. So uh, main thing was the digital twin is high cost. So accuracy. So in order to, if you need to get accurate subsurface investigation, the cost will be much more higher. So by using digital twin, we can minimize that cost, and we can able to predict all these challenges in the site. So advantages of digital twin. So by implementing the real time data, we can also have many advantages. many advantages, including integration of diverse data sources, combines geotechnical data such as lab test, borehole reports with real-time sensors and inputs. We can also add for example, we can add thermal data, thermal sensor to get the thermal readings, and also risk mitigation helps predict potential failures by simulating scenarios such as slope, instability, or groundwater flow. Then optimization of designs enhances accuracy in modeling soil structure interactions, leading to efficient and safer geotechnical designs. Then real-time monitoring and decision making, which enables engineers to monitor ground behavior and adapt to changes during the construction and operation phases. Then components of digital twin. These were the major components involved in digital twin. First one is physical asset. In geotechnical, we will consider as subsurface materials, structures like tunnels, foundations, or slopes. Then digital model. So 3D models, GIS and simulation tools. So by carrying out the 3D models and using GIS techniques, we can develop a digital model. Then data connectivity by using the IoT sensors, drones, so geophysical instruments, we can have a data connectivity. Then analyzing and prediction. So analysis and prediction can be done by AI and using machine learning algorithms for data interpretation. Then technologies enabling digital twin. First one is drone photogrammetry. By using that, we can able to analyze the terrain modeling and subsurface and the surface conditions. Then GIS integration. So location-based data can be collected, and we can able to monitor based on the location. Then sensors and IoT, real-time monitoring of ground improvements and pore pressures. Also, we can able to identify by using the sensors. Then BIM. So for detailed 3D design of geotechnical structure, we can use BIM. Then AI and machine learning. So patterns recognition and predictive analysis can be done by using AI and machine learning. So applications in geotechnical engineering. So main applications will involve in slope stability analysis. So by using the real-time data, we can monitor the landslides and soil erosions. Then foundation engineering. So predicting settlements and load-bearing capacity can also be predicted by using the digital twin. Then in tunnel construction. So, if we take the tunnel construction, there are a lot of uncertainties and many problem arises in the tunnel construction. So, we can also predict those problems and uncertainties before the start of construction of tunnel work, and we can also minimize the problems. Then, earthquake engineering is simulating the seismic responses of soil. So, in earthquake related works, also we can able to predict the seismic responses. Then groundwater management, monitoring aquifer depletion and recharge can also be done. Then challenges and limitations. So in digital twin, in fact we have a lot of positivities. We have also some of the challenges and limitations. These are the some of the challenges. So high initial setup cost. So the setup cost is very high. For carrying out one project, you need to have a certain workstation, and you need to have a group of team members. So the initial setup cost is very high. So integration. Then we are also implementing many IoT sensors and technologies. So these IoT sensors will be much more costlier. So integration of the data, so many heterogeneous data you need to integrate in this. So that data is also very difficult to implement. Uh, so expertise requirements for advanced simulation. So you need an skilled and expertise individual to handle these kind of projects. So dependence on sensor accuracy and connectivity. The accuracy of the sensor must be very high, and you should reduce the error in the sensors before going to into the process. So this was the one of our project that we have been carried out, that is digital twin for lakefront development. This project was one of the PWD project that recently we have been worked out and finished it out successfully. So I am going to explain you the entire project from beginning to the till the end. Uh, So first one aim. So the aim of the digital twin for lakefront development is to create a holistic and data-driven approach to planning, management, and decision making, ultimately leading to the creation of vibrant, resilient, and sustainable lakefront communities. So the problem statement that has been given by the local people to the PWD people to us was the Kanjipuram, that city area was full of temples. So they plan to create another park-like thing for their lakefront communities in order to develop the income for the nearby areas and order to develop the lake region also. So for that, this was the plan we have been proposed. The main objectives was creating a highly realistic interactive 3D model of the lakefront area to visualize proposed development plans, including landscaping, buildings, walkways, and recreational areas. Then tracking and visualizing environmental data such as water quality and wildlife habitats. Then enhancing the digital twin experience with AR and VR applications, allowing users to explore the development in an immersive environment. So the scope, first we need to do is the study about the water quality. Then we did the tourism planning, then scenario analysis for future development, and finally AR VR visualization. Due to the pollution by the nearby settlements and dump yard. So if we see this, this is the lake image, Google Earth Pro lake image. So in this, these were the nearby settlements in the lake region. The nearby lake bund is fully covered by the settlements. So the nearby people, they used to dump their waste into these water area, and this is also this also caused pollution. And other than that, the Kanjipuram district total dump yard is located at this region. So this dump yard is also affecting the nearby lake regions. So you can able to clearly visualize the lake colors also. So this was some like the water is in good condition, but in this area the water has been a little bit contaminated due to the dump yard and due to the human activities also. So the next thing is encroachment. That only is recently seen that the nearby dump yard people, the nearby township people have been polluted the lake region. So due to the settlements, so this also caused a major problem there. Then impact of climate change. So due to the climate change, the water in lake has also been little bit dried up. In order to overcome these problems, we have been created a digital twin model for this lake. So this was the methodology that we have been carried out. The first one, this was the three concepts we have been carried out. First one was requirement analysis, then data collection, then digital twin model creation. So in requirement analysis, we did the project planning. So in this planning, we included all kinds of data, including how drone data. The next thing we analyzed was the scope, then timeline, and finally milestones. So the in planning phase, we did all the kinds of data collections from the drone imagery, so photogrammetry data, then lidar data. So all this data we have been collected. So in the next process, we did the integration of GIS data. So the topographical maps we have been obtained from the Landsat data, uh, using the Landsat data, and also we have been got the data from the Bhuvan website. So based on the data, we did the lake environment assessment. So in the analysis part, so from the drone data, we took the drone, and by means of the drone we collected the digital surface model data and digital terrain model data. Based on that, we also calculated the contour, elevation profile, and other water quality parameters also. So then the third thing is digital twin model creation. So in digital twin model creation, the main thing stands was usage of Unreal Engine, then asset creation and integration, simulation, and finally interaction and visualization through augmented reality. So basically, the Unreal Engine is a software that is mainly used for the game developers for the development of games, several games. So we used that software. So this was the methodology that I have been adapted. So for the digital twin concept, everyone can adapt their own methodology. You can also implement your own methodology in this. So this was the methodology we carried out. So we use the Unreal Engine, and asset creation has been done by using the Blender software. So we have been integrated the Blender software and Unreal Engine. Then finally, by using that, we have been created a 3D work environment. So first we start from the field data collection. So first, by using the drone, we collected the field data. So the drone we used was the DJ Mavic 3 Pro. So this was the drone we used. So then the next thing is marking ground control points. So the ground control points are important for the accuracy and precision of the drone image. So for that, the planning and preparation that we have been done is the identifying the area of interest, then determining the number of GCPs and the equipment. The equipment that we used for the marking of GCP were RTK DGPS. So based on that, by using the device, we have been located the GCPs. So the more number of ground control points you locate, the more number of accuracy you get. So we have been identified only 5 ground control points. So in case of more accuracy and precision, you need to take more number of ground control points. So the RTK DGBS instrument. So at first you need to select the location for the ground control point. So for this purpose, we use the Google Earth Pro software. So by using the Google Earth Pro, we have been located the five ground control points, including the base point. So the base point we have been located on the northwest part of the lake region. Then we have been located the other 4 ground control points. So the ground control points should be uniform and evenly distributed, and it should have a high visibility. So it should not be covered with the any trees or any buildings. So it should have clear visibility from the sky. Then it should be accessible. So it should be easily accessible for you to collect the data from there. So marking of ground control points. So the ground control points marker should be at the minimum length of 2 meter into 2 meter. If you increase the size, you can have the clear visibility. The larger the size of the marker, you can get the clear visibility by the drone from the sky. So placing the markers at the different parts of the lake region. So with the help of the base, the calibration of the instrument will be done by using the base and rover. So we used to call this as a rover and this as a base. So by using the base and rover, we will calibrate the instrument. Then after the calibration, we would take the rover. So we will take this rover and we will mark at different ground control points, 4 different ground control points, and we will note the latitude and longitude of the ground control point by using the RTK DGBS. So these were the ground control points detail. So this detail you need to be noted at the site. So first you need to identify the ID. So these IDs will be created by you. For example, I have been placed as a base one point name, then other GCP 1 2 3 4. So you can name it as yourself. So you can also give it a different names. Then the area of identification. So in order to, you need to identify the area where you have been placed the GCP. So in order to identify that, we have been noted the areas like water float area, silt land, village grass, so police station. So based on this, we can able to easily identify where we have been placed the GCPs. So next one is preparing the flight plan. So for preparing the flight plan, we need to identify the boundary of the Nathambete Lake. So then we need to check the weather forecast. So in order to fly the drone, you need to check the weather. So if the weather is, you can fly the drone only in the sunny sky. So during the rainy season, you can't able to fly the drone, and cloudy season also you can't able to try the drone. So you need to check the weather. So then initial drone setup would be done. Then flight planning. So for the flight planning, we can use Google Earth Pro. So then setting the flight altitude. The flight altitude is we set was approximately 110 meters. So if you increase the altitude, you would get the large area covered. So if you decrease the altitude, the area of coverage would be very less. Then before flying the drone, you need to check whether that area comes under the red zone, yellow zone, or green zone. If it comes under red zone, you can't able to fly the drone there. So red zone, the areas located near the airport region would be come under the red zone. Then the yellow zone, if it's a yellow zone, you need to get the permission from the local authority or any police station, and you can able to drive. So in green zone, you don't have any problem, so you can fly your drone. So the Nathambeti region that we have been fly the drone is comes under the green zone. So this was the flight plan we have been done by using the Google Earth Pro software. So this flight plan would be imported as a CSV file into the drone remote controller. So based on the flight plan, the drone itself automatically it will take off, and it will measure from the base to till the end by using the flight plan. So these were the drone aerial images. So from the drone aerial images, we can able to clearly identify the ground control points we have been marked. So in the first image, here is the ground control point. In the second image, it's located here. So if we zoomed in, so we can have a clear visibility. So there is no trees hiding our ground control points. So we can have a clear visibility of the ground control points. So then drone data processing. So for that, we need to transfer the data. First, we are flying the drone, and we are capturing all the images by using the drone, and and we are organizing the images based on the ground control points. So we might have a cluster of images. For this process, we had more than 5,000 images. So all these cluster of images we need to combine into a single image to obtain the specific lake area. So this like small areas, we would have a cluster of images. So we need to combine all these clusters into a single image. So for that, these are the details we required. First, we need to organize the file based on the ground control points. So the next thing is we need to geotag. So each and every image need to be geotagged. So basically, the lidar-based zones would have automatically geotagged images. So the image that you capture by using these drones would be geotagged. Then by using the software, Fix 4D, Agisoft, Drone Deploy, DJ Terra. So by using any one of these software, we can able to process the drone images. So this was the orthomosaic image of the lake. So the cluster of images have been combined and formed a single image by using the drone data. So the single image have been formed. So this we would call as orthomosaic image. So in this image, the area would be clearly identified. So then the digital surface model have been created by using the orthomosaic image. So if you import the orthomosaic image at the ArcGIS or QGIS software, you can able to calculate the digital surface model. So in the digital surface model, the finding we have got was the color gradient that represent the different elevation levels ranging from green to yellow and red. The green region would have the low elevation. So here you see the green region, it would have low elevation, whereas the yellow region would have the yellow and red regions would have a higher elevations. So based on that based on this digital surface model, the elevation would have highest at 1 or 2 meters and the lowest is of 41 meters. So then digital terrain model. So the provided image is a model of digital terrain model of the Natambete Lake, which depicts the ground surface elevation without any surface features like buildings or vegetation. So based on this, we can able to identify the terrain feature of the lake. So this contour. So in the based on the contour. So this contour can also be generated by using the orthomosaic images. Uh, so this was the elevation profile, then findings. So based on the elevation profile, the minimum elevation for that lake is 92 meters and the average elevation is 97 meters. Then the maximum elevation is 103 meters. So there is only a minor elevation fluctuations in this from the elevation report of the Nathampete Lake. So water quality parameters. These are the water quality parameters we have been analyzed. First one is normalized differential water index, then turbidity, water ratio index, suspended particulate matter, then total dissolved solids, and simple water index. So first we identified was the normalized differential water index. So we generally used to call this as NDWI or MNDWI. So in this, the red indicates the region of significant presence of water, where the highest value indicates the 0.29054 meters. So the presence of water is high at these regions. So this is been indicated in the red color, and the blue regions indicate the presence of lower presence of water. So in these regions have been human settlements, so there is no presence of water. So this area will be indicated in blue color. So likewise the vegetation. So this blue color also denote the vegetations and also human settlements and build up areas. So turbidity. So turbidity can be calculated by using the software ArcGIS or QGIS. So turbidity is calculated by using this formula. So all these RGB band data, so red, green, and blue. So these were the RGB band data. So these data you can gather by using the uh, Landsat data. So Landsat would have all these data, and by using the Landsat data, you can calculate all these turbidities and these things. So in this turbidity report, the areas with the red and yellow color indicates a higher turbidity level. So these areas would be of red and yellow color. So this would have a higher turbidity regions. So where so the blue area represents the lower turbidity levels. So if we have the lower turbidity, so it would indicate the presence of water is clear. So since this water is used for the irrigation purpose, so this turbidity is calculated by using the formula that has been used for the calculating of normalized differential chlorophyll index uh, by using the GIS software. So as like that, the red area in the map indicates the higher concentration of chlorophyll. So in the blue area represents the lower concentration of chlorophyll. So comparing to other regions, the chlorophyll concentration is very less at the lake water area. So the water is so these parts of the water would have less algae presence and also have the clear water. Then simple water index. So simple water index is a remote sensing index used to identify the quantify the presence of water bodies. So higher SW values indicates would be indicated in lighter color, and the lower would be indicated in darker color. So suspended particulate matter. So suspended particulate matter. Uh, we would calculate the suspended particulate matter in order to identify the total number of suspended particles present in the lake region. So this can also be calculated by using the formula. Uh, so the darker shades would be indicated the lower concentration of suspended particulate matter, while the lighter shades would have a indicated higher concentration. The color gradient from blue to yellow indicates varying levels of suspended particulate matter, with yellow representing higher concentration and blue representing the lower concentration. So the next thing is total dissolve. So the TDS values. So higher concentration of TDS are indicated by red colors, while the lower concentration is shown in blue. So the TDS value in water is very less. So it's a good and clearer water. So then next thing is process in Unreal Engine. So we have been calculated all the water quality parameters, and after that we need to create a 3D asset. So in order to create a 3D asset, the first thing we use is drone image. Then the drone image is converted into a 3D image. So in this we are going to detailly study about the process. So for the first step we done here is drone photogrammetry. For that, the drone with the high resolution camera we used. Then the photogrammetry software, for example, Fix 4D, Agisort Metashake. So in these two software, you can use any one of the software. So by using this software, you can import the drone images into this software, and you can you can combine the drone image into a single 3D format. So the single 3D point cloud format. So that point cloud format can be transferred as last data. So LAS data would be we are using in the Unreal Engine. So for each and every work, we would have a separate data format. For example, the shape file would have SHP format. For likewise, the point cloud data would be have the LAS format. So LAS data would be used in the Unreal Engine. So the next thing is creating the 3D model. So we need to create buildings, so bridges, so all these things we can create by using the Blender software. So based on the Blender software, we created all the 3D assets. Then the Unreal Engine for visualization and digital twin. So for the visualization and digital twin process, the we used the Unreal Engine. So we used Unreal Engine. So for that, the first we exported the model from the Blender. So the Blender, so the first we exported the 3D. We created a 3D model by using the Blender, and we exported that 3D model into Unreal Engine. Then creating a new project in Unreal Engine. So before starting the project, we would create a new project in Unreal Engine. So then we imported the 3D model into Unreal Engine. So the 3D model would include all the models we done by using the Blender. Then we created a virtual environment. So the virtual environment has been created in the Unreal Engine. So we placed the 3D models, then adding the realistic lightnings. So the light day and night lightnings have been added. Then simulating of water and texture mapping also been done by using the Unreal Engine. So these were the assets we created by using the Blender software. So here comes the football court, then basketball court, then small dome which has been formed in the center of the lake, and we have also created a floating glass bridge at the one corner of the lake. So a boat house also been presented there. Then kids park, so advertisement boards, so parking areas, so shopping areas. So all these parks, all these assets we have been created by using the Blender software. So the for energy efficient things we used cycling. So we have also fixed the solar panels for the self sufficient. So the in this park, this entire area would be self sufficient for their electricity purposes. So this was the overall view of the lake digital twin area in Unreal Engine. So here now I'm going to show the video, final output video of our project. So this was the asset we have been created by using the Unreal Engine. So this was the final output of our project. So we have been submitted this format to PWD. So virtual 3D environment has been created by using the Unreal Engine software. So inspired, this is a bird watching area. So we created the watchtowers to clearly watch the birds and to take photographs. So this was the floating glass bridge. So the beauty of the lake is that it has the railway track in the middle of the lake. So this would also add up the beauty for this lake. So if you see through the virtual reality lenses, you can able to get the clear visualization of this entire project. So you can feel the live experience in this. So this was the final output of our project. So in conclusion, overall this project is poised to transform Nathambete Lake into a vibrant, sustainable and multifunctional space that benefits both environment and community. So that's all to end the session. If you have any doubts and queries, you can ask. Thank you. Thank you, ma'am. Thank you for the opportunity. If you have any doubts, you can ask.
Thank you, sir.
Thank,
Participants, the session is open now for discussion. Is there any questions from the participant side? I think there is no questions from the participant side. Yes, I think there is no further question from the participant side. So thank you, Stanley, for giving us this opportunity to present our project.